Hello, welcome to this new tutorial that will guide you on how to interface a push button with Arduino microcontroller. The push button here is used as an input device to the microcontroller, and we are going to see how to turn on a LED using this push button interface with the Arduino microcontroller. So the first thing is for you to select your devices. We are going to use the Arduino Uno. Double click on it, then you select the push button. You can type in here the push button to select an SPST push button. Then you select an animated LED. Animated LED, select green. Then you select the pull a resistor. So we are good to go. Input the various devices into the workspace, the Arduino, the LED. Let's connect the LED to pin 1 of our microcontroller. You can use any pin. Sorry, never connect the LED directly. Always use a protective resistor in order to limit the amount of current flowing to the LED. This is because the LED is driven by current, and a high amount of current will destroy the LED. In our previous tutorial, we saw how we can calculate the amount of resistance used in protecting the LED depending on the type of LED you use. Here we have a green color. Please refer to the previous tutorial in order to see how to calculate the protective resistance value. So you come to terminal mode, select ground, click on ground and click in the workspace to connect the cathode. Change the value of this protective resistor to 75 ohm. You can do the calculation or consult a previous tutorial to know how to do the calculations. Come back to component mode. Then we are going to connect the push button. To connect the push button, there are various topologies. Click on the push button, you can rotate. Here we are going to use the pull up mode. Select a resistor, connect it as such. Select a 5-volt supply, come to terminal mode, power, click here in the workspace and connect the supply, double click on it, choose VCC, which is 5 volt. Then connect the middle of this to any pin. Let me connect to pin 12. Still at terminal mode, select the ground and connect the push button here to the ground. So this configuration is called the pull up mode. We also have the pull down mode. You simply interchange the resistor, bring it down, and the push button bring it up. The pull up mode, when you supply as such, you see that this terminal at pin 12 of the microcontroller will be high because of this 5-volt VCC. Whenever you press the push button, rather than current flowing to the pin of the microcontroller at pin 12, since it is at high impedance, it will prefer to flow to the ground since the ground is at low resistance whenever you press. The reverse occurs in the pull down mode. The pull down mode, when you have the uh, push button up and the resistor down, you will notice that the push button up is always open and so no current flows from the source VCC here to the microcontroller pin. But when you press the push button, so it is constantly low, the pin of the microcontroller pin 12. So when you press the push button, when the push button is up and the resistor down, you'll see that it changes state from the pin of the microcontroller pin 12 will change state from the low state to the high state. Here we focus on the pull up mode. So we are good to go. Now let's look how to interface this using the code. Open your Arduino IDE. Then we have to configure the various pins. We have used pin 1 as the pin connected to the LED, which is an output pin. So configure it using pin mode. Pin 1 as an output. Then we have used pin 12 as the input pin of the push button. So write pin mode pin 12 as an input. So we have configured the various pins. Now go to the void loop, since the microcontroller needs to check constantly if you have pressed or not in order to turn on or turn off the LED. So here you need to detect whether the push button has been pressed using the if command. That if the push button is pressed, and how do you know the push button is pressed? You're going to read the terminal of the microcontroller at pin 12 using the command digital read. So if digital read at that pin is low, then we know that we have pressed. Why low? You know here that this pin is constantly supplied due to VCC here. It's constantly supplied. And when you press the push button, current will prefer to flow to the ground rather than flowing to the pin of microcontroller. So whenever you press this, the state at pin 12 changes from high to low. So you can know that you have pressed when that pin is low. So if pin 12 is low, then you turn on the LED using digital write. So if command, this is the if command, the condition here, if this condition is met, then in big braces, you write the function, what it has to perform or the operation. So you turn on the LED at pin 1 by giving a high state. What if that condition is not met? Then we use the command else if the pin at pin 12 of the microcontroller is high. That means that we have not pressed. So else only signifies that statement. So else we turn off the LED at that pin, which is digital write at pin 1 low. So we compile, done compiling. Then we search for the hex file down here. Here is a hex file. You copy from C up to .hex. Copy, and you go to Proteus, double click on the microcontroller, and you paste it here. Okay, so simulate. You'll notice that whenever we press, it comes on, and whenever we release it, it goes off. This is due to the fact that as the pin is turning on, as the pin 12 is becoming low, the LED turns on. But when you release your hand on the push button, it goes back off because the pin at pin 12 turns back to the high state as such. So this requires your hand to constantly be on the push button for it to be on. Or when you release, it goes off. So how can we modify this in order to turn on this LED once and continuously if pressed one time? So we have to modify this code. Okay, let's proceed. Come to the IDE, the Interface Development Environment. We can utilize a while loop in this operation such that whenever it detects that the push button has been pressed, it turns on this LED at pin 1 infinitely. So we are going to you put this operation in a while loop, in a loop, so that it doesn't step out of this loop. This is one way in order to do this. So we use the while loop by writing while 1 at this point, bracket 1, then the operation in big braces, open and close here, then end with a semicolon. Sorry, here, end with a semicolon. Compile. Then we come back to the Proteus environment. We stop the simulation and run. No need to replace the code because we have not closed the IDE. So it will recognize that the code has been modified. So if we press once and leave, you see the LED remains constantly on. Unlike in the previous case where your hand needs to stay on the push button. So the limitation of this is that here you cannot press for the LED to turn off again because it is constantly in the loop turning on that LED. For example, if we press the push button, it has no effect. In order to modify this code such that when the push button is pressed once, it comes on steadily, that is continuously, and when pressed again the next time, it goes off, and it can happen continuously in like manner. So where we have the LED turning on in our code at the point of the loop, we are going to add another if condition here so that when the LED is continuously on, it tests if the push button is pressed again. We are going to use the command if GETA read at pin 12. That means if pin 12 is pressed, because when it's pressed, the state of the pin there is low, then we are going to turn off the LED at pin 1 by giving a low state at that pin. So we are putting this in the while loop. So it is important that after doing this, we use the command return for the microcontroller to step out of this while loop. That means whenever it detects that the pin has been pressed again, it turns off the LED and steps out of that while loop to begin testing again if we press the push button or not. So essential to close the various braces. This bracket closes the while loop. Good. So we can actually run or compile. Sorry, we are still having another bracket to close this loop. Okay, so done compiling. We test, stop, simulate. Let's run the compilation. Press once, it comes on, and when you press again, it goes off. This is how you can modify the code and you can interface a LED with a push button successfully. Please remember to subscribe to this channel to receive much more tutorial and updates on the next video. Thank you.